we get to chapter 9, and this is ones involving alkynes. Okay, one thing back here I'd like to note. Actually, first let's talk about here. Okay, so if we have, it's a little less organized. So if we have two Br2s there, correct me if I'm wrong, I don't know since I've taught this. If we add 2 moles of NaNH2, that's all we need to add, right? Then we'll get our triple bond. Correct.
Yeah, that sounds right. We haven't covered a lot of this yet. In fact, I think today we're going to be talking about how there's a discrepancy between the two and needing 2 moles and 3 moles.
Yeah.
So,
okay, so you haven't done all the reactions, chapter 9?
We've talked about these.
Okay, we can just go over and then you can have them in a concise list. Now, the thing is, when you need 3 moles, it's when your 2 bromides are on like the end. One of them's on the end carbon, so you're gonna find.
So you have like a primary one then.
Exactly. Okay. You're gonna form a mono-substituted alkyne, and so you need to do 3 moles of NaNH2.
Yeah.
And then on your second step, that's your first step. I'm gonna put here 1. Your second step, you add water in there, and then you'll get your triple bond. And I'll show you why in a second, but you get your triple bond. Because the thing is, if you have a triple bond and it's monosubstituted, and you add NaNH2, and it's in your solvent NH3, you'll get a negative charged carbon at the end.
Yeah.
Now, I want to point out that it's probably good to include it here. And this is your acetylide, I think. If you have your negative, this guy, it will go by the same pattern as a strong non-bulky base here when they were reacting with an alkyl halide.
Yeah, it's a rather strong base.
It goes by SN2 for methyl and primary, but it will cause elimination actually if it's tertiary or secondary. Now, you can see why, if you think about it, this is the why you need 3 moles here, is because if you only have 2 moles, you might get some of them that get deprotonated to this negative charge, and other ones might get stuck in a double bond here. So what you do is, because you don't get to tell what NH2 like what to do. I mean, it might deprotonate. You add 3 moles, so you get them all deprotonated, and then you add water, and then you protonate them, so then you get your triple bond. So that's why. Now, a lot of the triple bond reactions are very similar to our alkene, except we don't have as many. Some of them don't work. Like for example, if we had HBr, we get, adding 1 HBr, we get a bromine off of the more substituted part of the double bond. And if we add a second HBr, we're going to have 2 geminal bromines. And I believe you could do anti-Markovnikov for this one. Oh, I should have probably talked about that guy first. Oh, will. Wait a minute, word. Doesn't feel like all of them. I hate how they don't always include like every single thing it talks about in the summary.
Yeah.
We'll talk about those. That's pretty. And then, yeah, if we add HBr with peroxides, we'll get the anti-Markovnikov. So you can see, like, I mean,
Really similar stuff.
yeah. And I think this one, if I'm not mistaken, I think it only adds on once. I hate how sometimes they don't state that. Now, one that will be semi-confusing is you can add like your H2SO4 and you can add water, but it doesn't really work. It ends up forming a ketone in the middle, actually, which is kind of cool. You haven't learned how to make ketones. And it actually works better if you add a mercury ion in there.
Okay.
It's a weird one. So there's no way to form an alcohol from a triple bond directly. And so this reaction, our H2SO4 with water, they had them, it doesn't really work, but if you add mercury in there, you get this nice ketone there.
Okay.
And then the BH3THF, the anti-Markovnikov, crazy one, don't even have to worry about it with the triple bond.
Okay.
They don't do it. Now, another one you can do, so we have our triple bond, we can add Br2, and we get our double bond, 2 Brs, but then if we add another Br2, they'll add, so we can get 4 bromines off of it. Kind of cool. Yeah, that one. And then we don't have to worry about Br2 with H2O. We don't worry about epoxides, but you can do ozonolysis, and it gives you essentially the same thing, but with a slight difference. Let me just double check to make sure here. With a slight difference that before it mattered if we added zinc or not.
This time it really doesn't.
This time adding zinc doesn't do anything, but so you'll still get carboxylic acids on both. So you get those two products. I didn't show that the best. And then I should have put this up at the top to be consistent. Oops. So then if we have our triple bond and we add H2 with like some sort of nickel, we can get down to a double bond. And if we add it again, we can get it down to our alkane, or if we want it to be a certain If we want to stop at a double bond, we can add H2 with Lindlar palladium. Has she gone over this one? Okay, and I actually should go like this. This should be, we should draw a triple bond being in the middle of the chain on this guy. So if I do this with Lindlar palladium, make sure we get a cis. We get our double bond stopping at cis.
Okay.
Whereas if we add, this is kind of weird, to get it to stop at trans, you have to add H2, sorry. You have to add Na with NH3. Not, this gets confusing. It's not Na NH2 like these guys were, it's just Na, comma, NH3. And then we get our trans double bond.